Hello, and welcome to this session. In this first video, I'd like to do a really quick introduction to the impulse momentum apparatus that we're going to study in today's session. So the apparatus that we're going to explore has the following components. We have a yellow inclined ramp, and resting on that inclined ramp is a red cart. The cart has wheels, and the red cart can roll down the ramp. When the red cart collides with the green stopper exerts an impulse force onto the red cart, which in turn pushes the cart back up the ramp. You'll see that the green stopper is attached to mechanical ground via a mechanical spring, a spring that has a stiffness value and a damping value. You'll see that in the schematic that's in the center of the screen, we've got a number of geometry parameters. For example, L2 is the initial separation distance between the front face of the red cart and the green stopper. So before we open up the Simulink model, we need to run this parameter script. So let me sort of click on the Live Editor tab sheet and then click this green run icon. So this runs the script, which as I sort of scroll down it, you can see the MATLAB statements that create MATLAB variables. In these MATLAB variables, we assign numeric values to things like L2, the mass of the red cart, and so forth. After you've run this parameter script, you should see the following variables in your MATLAB workspace. And these variables are going to be used within the Simulink model that I'm about to open. So the parameters have been defined in the workspace. Now let me open a completed Simulink model of the system. So here's the Simulink file. And you'll see on the left-hand side of the Simulink file, we have the model browser. The model browser shows the tree view of all of the subsystems that are inside the model. So let me sort of click on the subsystem called the model. So here are the Simscape multi-body blocks that we've used to represent the system. And I've color-coded the blocks with the same colors as their corresponding elements in the schematic. So for example, this yellow block represents the inclined ramp. This red block represents the cart. This green block, yep, it represents the stopper. What I'd like to call out while we've got the stopper block on screen is that we will be ignoring the mass of the stopper. We've assigned the green stopper block a very, very low value for density. Its mass is negligible for this experiment. You don't see any wheels in this sort of model. That's because what we're going to do is use a prismatic joint, the very first prismatic joint I'm clicking on now, the blue block, and that prismatic joint constrains the red cart to a purely translational motion. In fact, it constrains the cart to being able to move only parallel to our yellow inclined ramp. Yeah? We also have another prismatic joint that sort of connects the stopper block. Let me open up the second prismatic joint, the one that connects stopper block to ground. And you'll see that this is how we sort of specify the mechanical spring stiffness and damping that's shown in the schematic. Just a couple more things. The red cart and the green stopper, whenever those two bodies come in contact, we've got this spatial contact force block that is able to then generate an impulse force, a force from the green stopper onto the red cart and from the red cart onto the green stopper. And this spatial contact force block is also how we actually measure what that impulse force is between the two bodies. Yeah. Okay. Last thing to call out that I think is useful to know is that in the model I've also defined a series of inertial reference frames: the red frame, the pink frame, and the blue frame. And these frames have origins as shown in the schematic. Here's the origin of the blue inertial frame, the pink inertial frame, and the origin of the red inertial frame. All of these fixed inertial frames are all orientated as shown by this XY diagram. positive x-axis of the inertial frame is parallel to the ramp, and its positive direction is pointing to the right. Okay, that's the model. Yeah. One last thing before we sort of press the simulate button is let me take you into another subsystem, the sensors and data logger subsystem. So inside this subsystem, we actually sense or measure things in our model. The specific things that we're going to measure is the position and velocity of the front of the cart according to an observer stationed at the red 03 inertial reference frame. Yeah. So according to this point right here. You'll see that we've also got an oscilloscope, and in that oscilloscope we're going to be plotting the position of the red cart, the velocity of the red cart, and also the impulse force exerted onto the red cart. Okay, enough talking. Let's simulate this model. So click on the simulation tab sheet, look for the green run button, and click it. And because this model contains Simscape multi-body blocks, you can see this beautiful CAD-like viewer appears. Yeah. So let me just sort of zoom in on the sort of green stopper. And what I'll also do is just sort of dial back the playback speed, yeah, to about half speed. Let me replay this animation recording just by clicking this icon at the bottom of the screen. And just watch what happens as the red block makes contact with that green stopper. You'll see that the momentum of the red block sort of pushes on that green stopper and pushes it back ever so slightly. How far the green stopper is pushed back depends ultimately on the properties of the mechanical spring that attaches the green stopper to mechanical ground. All right, so you've seen the animation. What do the time traces of the red cart's position, velocity, and impulse force look like? Well, that's where this pink scope block comes into play. Let me open up the scope block. And here it is. So remember, in all of these oscilloscope blocks, the horizontal axis is always time. Let me just click this scale XY limits icon just to make sure all of the data fits in the axis. Okay, top axis is position of the front face of the cart versus time. The middle axis is the velocity of the cart. And the bottom axis is the impulse force exerted onto the cart. And look, why don't we click on this magnifying glass and just zoom in on the very first impulse force that gets exerted to the cart. Here's a better view of what that impulse force looks like. Okay, so that's the model. Let me sort of now just do a really quick summary of the workflow between the MATLAB parameter script and your Simulink model. So let's go back to the parameter script. And what I'm going to do is I'm going to increase the angle between the yellow ramp and the horizontal. I'll increase it to, say, 10 degrees. And I'll also say that the separation distance at time 0 between the front face of the red cart and the stopper is 1 meter. Remember, because we've embedded these interactive widgets into the script, when you modify these widgets, it runs the section of code that those widgets are in. All right, so we've now got updated versions of our model parameters. Let's go back to our model. I'll just sort of zoom out. And let's sort of run the sim again. Yeah. So to run the simulation, all we need to find is one of those green icons, whether it's in the model editor or in this Mechanics Explorer, it doesn't matter. Find the green run icon and click it. And you can sort of see that our inclined ramp is slightly longer, and it's at a larger a slope angle than we had before. Yeah. Okay, so just summarizing the workflow. The workflow is go to this task 1 MATLAB script, and then modify relevant parameters within the script. If you modify the parameters that have the interactive widgets like slider bars or drop-down boxes, you don't need to press the green run triangle. If you modify any of the other parameters, you will need to click the green run button. So make changes to your model parameters using this script, and then go back to your Simulink model and simulate the model by clicking this green run button. Okay, that was a really quick intro to this Simulink model. Talk to you soon.